Okay, then this is ClO2 or CO2, and we are here at CO2. And the statement for this CO2 is determine various search strategies, including blind search and heuristic search. So we have to cover this blind search or heuristic search. The other name for blind search is uninformed searches, and the other name for the heuristic is informed search strategies. So we will see them one by one, but before that, we will see the very fundamental short algorithms. One is tree search, other is graph search. Before actually starting the blind search and heuristic search, we will go with these two short algorithms. So to start with the tree search, we are going to see a Romanian problem. This is the map of Romania, which is a country. And here our agent is at this initial state, Arad. Arad is the initial state for the agent. And Bucharest is the final state for the agent. The agent wants to go from this Arad to Bucharest. And then we will consider this map. I think I already discussed that there are different possibilities to reach from this Arad to Bucharest. I don't know, because there is a mix of classes. There are 4 different classes that I am teaching. So I don't know. I talked with you already or not. But anyhow, so one way to reach from this Arad to Bucharest is this one, going to Zirin and then Oradi and then Sibiu, then Fagaras and then Bucharest. I think I already talked with this class, huh? Or not? The different paths. Anyhow, okay, if not, then let's have a look. So the other path is going from Arad to Sibiu and then Rimniku Vilsia and then Patisti and then Bucharest. And the other path is going from Arad to Timisoara, then Lugoj, Mehdia or Mehadia and Drobeta, and then Craiova, and then Rimniku Vilsia, and then Patisti, and then Bucharest. And similarly, other path is, so in the same way, but here, Craiova to Patisti, and then this. So there are different possible paths from Arad to Bucharest if the agent want to go from Arad to Bucharest. But there would be one optimal path in between these 4 paths. And that optimal path is this one. Huh? This is the shortest path. Shortest path. I can use a different color so that you will understand. So this is the shortest path. Every search strategy will try to find these paths. Some search strategies can give you the optimal path, some cannot. And due to this property, you will say that this algorithm is better in giving a solution or whatever. There are other things that you have to consider, which is called efficiency, which means the time that the algorithm will take to find the shortest path, and the space, which is the topic of algorithm, but we are not going into that detail. So every search strategy, you can apply different strategies here to find the solution for this problem. And every search strategy will try to give you an optimal solution for that. And optimal is what? Optimal is this path, which is the shortest one. Anyhow, so now moving next, we have now a background of this Romanian problem. And now the topic is tree search. So I talked with you that we will first discuss these short algorithms, tree search and the graph search. And then we will move on to our searches actually. First, blind search, which will have these categories in your textbook, and then the other one, heuristic search. So here we are on the tree search. This is very much simple search strategy. It is like a depth first search, but only one difference from depth first search, that you have a repetition exists in this version. So repetition of states exist in this version. You know what is state, huh? Because we already talked with state space problem. So if you have a problem, then states are there. Actions are there. Initial state is there. Goal state is there. Path cast is there. We already talked these 5 different components for any problem. So now, if we will apply this tree search over this Romanian problem, then what will happen? We will see. So first our research will start from here, from Arad. And then from Arad, our tree search algorithm will see how many different actions are available on this state. One action is available from, if the agent is going from Arad to Zarin, this is one action. Another action is from Arad to Sibiu. Another action is from Arad to Timisoara. So when tree search algorithm will execute, the root node is, the initial node is Arad. And after that, the tree will have these 3 options, Srend, Sibiu, and Timisoara, which you are seeing here. First is Arad, and then from Arad, you have 3 options, Srend, Timisoara, and Srend, according to the map. So now this is done. This Arad is now expanded. This is now, initially, this was the only one node in the frontier. Frontier is what? Frontier is a queue. Okay. Queue is a data structure, you can understand. Frontier is a queue, and queue can be LIFO or FIFO. Huh? First in, first out, or last in, first out. So in this algorithm, frontier is a queue. Or you can say it is an array, but it is a queue. In mostly algorithms which are coming next, frontier is there and frontier is a queue. So we will store first the initial node in the queue. Here it is stored. And then we will take it out. And then we will try to find its actions on the map. Okay, these are the 3 actions available in the map. And then we will expand that node. We will expand this node. We will expand this node after taking it out from the frontier. And now this expansion is done. And now these green nodes, which you are seeing here it was green. Initially, this green was in the frontier. It was selected and popped out from the queue. And then it is expanded. Now its color is some gray color maybe. And then you have these new nodes which you will put in the frontier. You will assign into the frontier again. And then according to the depth first search, you will select the left one. And then you will select from the frontier again, which is the first one from the leftmost. This is Sibiu. Okay, you will select that. And then when you will select that, okay, now it is selected. And now you have to expand it. And what are the actions available on the CPU? So if you will see, one is this action, Oradi, this is Arad, Fagaras, and Rimniku will see 4 actions are available. So that's why now we are writing those 4 possibilities, Arad, Fagaras, Oradi, Rimniku will see. And here, This was Arad initially, which we expanded. And here we have again Arad here on the left side. And if you will expand, what would be the expansion? Again for Arad, again these three actions, again these three actions, huh? So according to the tree, Arad has these three. So these three would be again expanded. These three would be again expanded. Okay, when you will expand it, you will have CBU or something like that. So this tree will be expanded again next. This tree will come again and again. And you will not execute, your algorithm will not be in a position to execute these nodes because here you have repeated states and here you have a loopy paths. Here you have a repeated state or loopy path, something like that. So in a tree search is what? Tree search is like a depth first search. And in this search, you will start from the initial node. You try to reach on the goal node. But repetition is there. Repeated states can be there. Can be. I'm using the word can be there. Sometimes it will not. And then you can reach on the goal. But if repeated states are there, you cannot reach on the goal node. It would be infinite state. And you will repeat that thing again and again. And your algorithm or program will be in infinite state, infinite loop. So here is that algorithm which we talked about. Let's see that. So function, the name of the function is tree search, and you are passing and we are passing some problem into it. Here the problem can be Romanian problem with all its information, that initial state, goal state, all nodes. So that's why this is a general word. It means we are passing information of the Romanian problem. And this function will return what? It can return a solution or it can return a failure. And this is a short one, so that's why we are not writing it proper mathematically. Here it is in a sentence form because only 2-3 statements are there. So let's see that what this statement is. Initialize the frontier. Frontier is what? Frontier is a queue. Okay. Initialize the frontier using the initial state of the problem. And what is the initial state of the Romanian problem? Initial state is Arad. Initial state is Arad. So in the frontier, so if we have a frontier, this is very hard for me to write something with the mouse, huh? So in the frontier, now we have what? In the frontier, we have Arad. I am writing only due to this statement, And then we have a loop. And here we are saying if the frontier is empty, this frontier is empty? No, it is not. So then return failure. So this condition is false. So this condition is what? False. So we will not execute it and we will come to the next statement. The algorithm will come to the next statement. Here, what is written here? Choose a leaf node, which means choose a node or leaf node. Okay. Leaf nodes are normally in the frontier. In the frontier, what are the nodes in the frontier? Leaf nodes. So choose a leaf node and remove it from the frontier. In the frontier, we have only one. So we will select this one. We don't have any other option. Okay. So we will select this and we will remove it. We will remove it from frontier and we will keep this node in what? In the node. Huh? You can introduce a new variable node and then you can put this removed item into that. So anyhow, so if I will write node, what is the value for my node now? So I removed it from there and I kept that here in node. Huh? So now after removing from the frontier, I kept this node, this which was a leaf node, in this variable. Now, moving next. If the node contains a goal state, I am checking that this node is a goal state. If it is a goal, then return the solution, otherwise not. So I'm checking this arad, whatever the value in it, this in this node, it is a goal? No. In Romanian problem, what is our goal? Our goal is Bukharis. So this arad is then not a goal. So then this condition is false and we are moving next. And here, expand the chosen node. Expand it again. Expand this node and add the resulting nodes to the frontier. So expand it, and whatever the next nodes are, you have to add them in the frontier. So okay, now you will look on the map. Arad has what? Srind, Sibiu, Timisoara. Yes.
For research, is there a particular order that we're looking for?
No. You can change the order. Okay. You can change the order. You can write Timisoara first and Sibiu here. And then maybe you will reach on the goal node without repetition. So there's no particular order. It is, you can take whatever you want, and this is one order that you are seeing here.
So if individually I choose Temeswar
First,
and I reach my destination,
that is okay.
So
that's okay.
how do I now actually know the solution and another person doesn't reach it?
That is not an issue. That is not an issue. We are talking about a property of the tree search that repeated states are there. Okay, that's why we put the CBU there first to have an experience of that repeated state. If I will put the Timisoara first, maybe I will not have that option. For example, just have a look. If I will start from here, and if I will expand and I will put Timisoara here, okay. And what are the options next? Arad and Timisoara. What are the options for the next? In the tree, you have the Arad, and then what are the, you have three options. Timisoara, yes, Sibiu and Sren. I am writing just in any order. And Timisoara has further what? Two options. Now, if I will put Arad here, I will have the repetition again. And if I will put Lugoj here, I will not have. So this is what I am intelligently playing. This is what I am intelligently playing. But it can have that you have repeated state somewhere if you will go with some fixed strategy. Okay. So you can have repeated state. This is your repeated state. And then, okay, Lugoj has what? It has further two states. For example, Timisoara or the Mehdiya. And then now this Timisoara is repeated state. So repeated state can be any, because because on each node you are considering the previous path also which you already visited. You are considering that edge again. So due to that consideration, that repetition is coming or appearing in your search. Clear, I think, So now expand the chosen node and add the resulting node to the frontier. So okay, so I have this arad. Expand it, and now you are seeing that expansion here in this tree. I don't have to draw. So now this is selected and removed from the frontier, and now it is expanded here, in this order. You can use any order, okay? So here we have kept CBU first, and now we have expanded, and we have to add these nodes in what? In the frontier. According to this, add the resulting nodes to the frontier. So you have to write the things here. So you have CBU. What is then? Timisoara and Sarent. So Timisoara and the Sarent. Walaikum assalam. So you have some اختبار هنا? Yes. Okay. كم وقت؟ الآن أنا كلمت خطر من أول. اي غرفه اي كلاس روم. اوكي اول بليز شوف اي غرفه خالي we will go there.
طيب عشان لازم نشوف جدول. كم محاضرة؟ كم باقي نص ساعة؟
بس 2 ساعه.
2 ساعة. ايش باخذ ايش فاضي؟
اوكي
جدول عند الدكتور أحمد.
اوكي so STZ اختبار.
كل نهار هذا اسوي نظافة اسوي كله وجهاز.
اوكي
اختبار انا اتكلم قبل اسبوع. اليوم في ستودنت كلهم برا جامعة. يجي.
اوكي متى اختبار ابتداء؟
انا في التجهيز كله اجل.
اوكي finish this topic and then we will talk about it. Okay, for this movement we will see. So add the resulting nodes to the frontier. So we are adding these nodes into the frontier. Okay, so STZ. So this is something you added. So after that, we will go again to this loop, and we are checking if frontier is empty. No, frontier is not empty. We have new nodes here. And then what? Choose a leaf node and remove it from the frontier. So now choose. So now I am choosing. Okay, I am choosing this CBU according to that tree. Okay, according to that tree, I'm choosing that CBU. So choose it and remove it. Okay, I have removed it and I have now written this CBU here in the node. And then if the node contains a goal state, this CBU is goal. No, it is not. So then what I am moving next to this statement, expand the node, expand this CBU and add the resulting nodes. So, okay, I will see from the map and I have these 4 options. According to the map, I have these 4 options. According to the map, I have these 4 options. So now expand it. I expanded and write them in the frontier. So these are what? Arad, Fagaras, Uradi, Rimrikuvilsia. So now you can write Arad, Fagaras, Uradi, and Rimrikuvilsia. So now next, now this is ended, and now you will go again in the loop. And now if frontier is empty, no, it is full of nodes. Then choose a leaf node and remove it from frontier. So now some student can select this Timisoara, but no, I have to select this Arad because it is in the tree. On the left side, according to the depth first search, on the left side, according to the depth first search, you have this one because I told you that tree search will execute like depth first search. Whatever you have in the left, you have to execute it. So here we have this Arad here. So it will be selected, and then what? This tree will be repeated here under it. And then you will reach again on this Arad, and then this tree will be repeated again here, and you will go into an infinite loop. You will go into what? Into infinite loop. This infinite loop is giving you a hint that you have a loopy path, or your algorithm will go into a infinite state or state spaces. Because states will generate again and again and again and again. So this is what infinite state space is generated there. And moreover, here we are saying that the goal test, which is here, before the expansion of each node. Here we are expanding the node, and here the goal test is before this statement. Maybe we will change this and then we will have our issue resolved. We will see it in the next algorithm. Okay. So this is one point. This is another, that we have loopy path. We have to remove these loopy paths. And how we can do that? The other name for these loopy paths is redundant paths. Redundant path means repeated paths. Okay. So we have to remove it to make this tree search better. Otherwise, this tree search is not a good search. Okay. So that's why we have this graph search in which this repeated thing is now removed, and the nodes which we already visited, we will not visit them again. Okay. So that is the logic here in graph search. So let's stop here and then we will start it again. Let's have a look what he is saying. I'm going to see some room if it is available. Huh?
Come here in another lab, which is 108, huh?